Remember the huge antenna near Chernobyl? Over the horizon is the Duga radar station, one of those objects that, thanks to its size, can be seen today from almost anywhere in the Chernobyl zone. 3 such antennas were built in the Soviet Union, in Chernobyl, near the city of Komsomolsk on the Amur, and in the city of Nikolaev. Only the Chernobyl arc survived until today. The others have already been dismantled and tried for metal. Since then, radar stations beyond the horizon have not been built, but some time ago in Russia one such antenna was still built. Why did they decide to come back to these huge strange antennas again, and how is the Duga station in Chernobyl connected with psychotronic weapons? Before I start answering these questions, subscribe to our channel, where interesting materials come out. Thanks in advance. In the summer of 1976, shortwave communications around the world were terrorized by strange interference. A distinctive signal with a frequency of 10 pulses per second was tuned to various frequencies for civil and aviation communications, interfering with radio transmissions in many countries. The signal, after operating for a few minutes on one frequency, would switch to another. Trouble and inconvenience led the armed forces of several countries to try to locate the source. It turned out to be deep in the Soviet Union. The signal, nicknamed the Russian woodpecker at the time, regularly intruded into frequencies intended for aviation. The United States and Great Britain took the opportunity to protest to the Soviet Union, but the Soviets said they knew nothing about any signals. Despite the results of a directed search, they stubbornly refused to recognize the source of the signal. It got to the point that radio amateurs tried to jam it by transmitting a similar signal in counterphase. However, it turned out that the Russian woodpecker had an incredibly high power. There were all sorts of speculations about the signal. They said it was a secret Russian weapon for controlling the weather or influencing people's minds. The idea that strong shortwave radiation could be a psychological weapon was quickly picked up by military and scientific organizations. The signal disappeared from the airwaves in 1986. It is likely that foreign intelligence services were able to trace the origin of the signal even earlier, using satellite reconnaissance, but this information is hidden in their archives. Only after the collapse of the USSR did the public learn why the Union did not recognize the existence of the signal. Its source was a secret radar station in the forests of Ukraine called Duga 1. Why were radar stations even needed after the bombings of Hiroshima and Nagasaki? Russia faced a new threat. The United States had a significant advantage not only in the production of nuclear weapons, but also in the means of their delivery, namely strategic bombers. In 1949, NATO was created to militarily counter the Soviet Union. Thus, by the early 1950s we were already surrounded by a network of air bases with several hundred nuclear bombers on constant duty. With nuclear winter, non-supercomputers capable of calculating the transport of fallout between continents, and no satellites, radio reconnaissance was very limited. How could we know that hundreds of bombers were not headed toward Russia? Therefore, the Soviet Union began building radar stations for early detection of missile launches. It is known that the Earth is shaped like a ball. For this reason, an ordinary radar station cannot see what is happening near the Earth's surface beyond the line of sight. Placing radar stations on high surfaces and masts, of course, allows you to expand the radio horizon, to raise the radar station higher above the horizon. Can do this only long-range detection aircraft, but they also have significant disadvantages: the signal strength of airborne radars, the quality of reception and processing of reflected signals are limited by the weight of equipment, which is able to lift the airplane. In addition, such a reconnaissance aircraft with a huge amount of equipment is quite vulnerable to ground-based electronic warfare and various means of defeat. Radio waves propagate in a straight line, and since the Earth is round, a beam fired parallel to the surface will go tangentially into the sky. However, our planet has an ionosphere, a highly ionized layer of atmosphere that begins at about 60 kilometers altitude. The beauty of the ionosphere is that it can reflect short radio waves in the range of up to 30 MHz. This property is the basis of beyond the horizon radiolocation. The wave is emitted at a small upward angle, a small part of it ricochets off the ionosphere like a ball off a wall, falls to the surface and is reflected back. This idea was first presented back in 1947 by Nikolai Ivanovich Khabunov. He proposed this method for tracking high-altitude aircraft or strategic bombers. The main difficulty was that the wave reflected from the target was much weaker than the signal reflected from the ground. But in the 1960s, the scientific base allowed the development of prototype long-range radars. They were capable of detecting both bombers and ballistic missiles that left an ionized trail. Such stations made it possible to detect an intercontinental missile even at the launch in the first 3 to 4 minutes. A missile from the US to the USSR would have traveled about 30 minutes. That is, the Soviet Union had another 25 minutes to take measures to defend itself or launch a counterstrike. This outcome suited everyone. Therefore, in the mid-60s, the construction of the first experimental locator called Duga node near Nikolaev was started. The antennas of the node were huge. The station building was 90 meters long. It housed 26 transmitters, each the size of a small two-story house. A little later, as part of the missile surveillance project, it was decided to build several more different types of over-the-horizon radars. One near Chernobyl and one in the Far East, near the city of Komsomolsk-on-Amur. At the same time, in the early 70s, construction of the Chernobyl nuclear power plant began. The station Duga 1 was built near Chernobyl, as high power was required due to high losses during signal transmission. The receiving antenna complex of the Chernobyl 2 station required about 10 megawatts, and the power consumption of the Lubek 1 transmitter near Chernihiv ranged from 8 to 160 pulsed power. These are simply insane figures. This antenna was used to view almost the entire area of the United States through the North Pole. Each station has a field of view of 50 to 70 degrees, depending on the state of the ionosphere on the signal path. However, for the correct operation of over-the-horizon radar stations in determining the optimal path of the sounding beam, it is necessary to have accurate data on the state of the ionosphere. In order to obtain these data, a station of return inclination sounding of the ionosphere, a circle with a diameter of 300 m, was built. It was located there, in the secret city of Chernobyl 2. It was an additional device for continuous detection of the attenuation frequency, which would be less strong. This made it possible to adjust the parameters of the Duga antennas so as to receive only their reflected signal. Already in early 1986, it was possible to reliably detect spacecraft and intercontinental ballistic missiles launched from a distance of several thousand kilometers. For example, Soviet specialists were able to detect the explosion of the American Shuttle Challenger in 1986. But only the modernization of this antenna was not completed in time. On April 26, there was an explosion at the Chernobyl nuclear power plant, which was located a few kilometers to the north. Thus, combat duty for missile detection station Duga in Chernobyl ceased to carry already in 1987. It was mothballed, the year was disbanded, and the military unit that was engaged in its maintenance, the main systems and most of the equipment were removed from the station and taken to Komsomolsk-on-Amur. But the story of over-the-horizon antennas did not end there. Already in the 2000s in Russia were built several ZGRFLS radar stations, but they differed from the ARC and could see mainly only large-scale missile launches. This was the case until the container station appeared, which went on combat duty on December 1, 2019. The station's receiving complex is located in Mordovia, and the transmitter in the Nizhny Novgorod region. This location allows monitoring the airspace over a large area of Europe. A device that consumes several megawatts of electricity fires a series of pulses into the airspace of a potential enemy. As these pulses are reflected or unreflected from different areas, operators at the battle station can understand whether aircraft are flying in the area or whether a missile has been launched. The container station is an antenna field consisting of 144 masts each as tall as a 10-story building. Over-the-horizon radar station container is able to monitor the airspace at a distance of up to 3,000 kilometers, detecting targets of different types, including stealth and drones. After detecting an object, the station takes the target for escort, and there can be up to 5,000 such targets simultaneously. Thus, the container monitors most countries and can warn of an impending airstrike. Now perhaps the question is, why do we need these tan umbrella stations when there are satellites? Actually, the capabilities of the satellite constellation are greatly exaggerated, mostly under the influence of Hollywood movies. If you are interested, try to analyze Google or Yandex satellite maps. You will easily find images taken in different seasons. That is, it takes more than 1 month of work to fully cover the Earth's territory. Yes, of course, there are Hull satellites with similar antennas bolted to them, only smaller. But the power of such locators will be much less than the power of ground-based radar stations. We often think of satellite surveillance as optical observation, by eye, so to speak. But the military and air traffic control services do not need the appearance of aircraft. An airplane can be hidden from optical surveillance by ordinary camouflage coloring, clouds. Night will also hide any airplane. The end. It is very difficult to determine the exact position of objects. We must take into account that the ground radar station can be hundreds of kilometers away from the anti-aircraft missile system and give it the exact coordinates of the targets, because stationary objects are easier to link together on a single coordinate system. There is one more circumstance: the schedules of satellite overflight over each point of the planet's surface are known to the nearest minute and second. It is always possible to find a time when no satellite will see an aircraft over that point. Over-the-horizon stations, compared to satellite surveillance, have their advantages. So the construction of these strange huge antennas will certainly continue. At the moment, all the basic modes of the new arc in Mordovia have been worked out. And in the Far East, preparations for the construction of the second station container have already begun. In total, more than 10 such stations will be built. That will make it possible to cover a vast territory and even the adjacent airspace with a continuous radar field. So the work started by the Soviet scientist Khabunov and many other scientists and engineers will continue to develop. Who knows, soon such a brain burner will be built near your city, and you will be able to observe this strange military object with your own eyes. I hope it was interesting. Subscribe to the channel, write your comments to this video.